Denver. Welcome everybody to the combined Denver and Boulder Java Users Group. I'm Chris Winnick from the Boulder Java Users Group, and Greg was not able to be here tonight. We'll be doing abbreviated announcements to save on time. If you have something you want to give as a presentation or you want to see discussed, email us or reach out via the membership sites so that we can put a talk on based on that topic. We have giveaways for IntelliJ JetBrains licenses and Agile Learner training videos. Mike will be handling those. Be sure to check out the live chat comments for a link to enter the raffle. I want to thank Zeddy Chinfong, Mike Suedo, Matt Rabel, and Greg Ostrovich for running the Denver Java Users Group. We will not be meeting in July due to the hugely popular Uber conference at that time. Be sure to check out on the Denver or Boulder Java Users Group meetup pages and attend if possible. Tonight's speaker is Kito Mann, who is a principal consultant at Vertura Incorporated. He's going to talk about GraphQL. It promises to simplify the backend, give the client more power, and make it easier to evolve APIs. Thanks, Kito, and over to you.
Okay, welcome. Got a little intro for you, so I'll start with that. And let me make sure my screen is being shared. There we go. Okay, so now hopefully you're ready for some GraphQL. So that's an intro from my son who's 8, and I noticed my kids are making all these little multimedia intros. So I was like, hey, I'll just use them in my presentations. Great deal. So anyways, so this session is called GraphQL Distilled, and I do a few different variations of this talk, but this one is more aimed towards Java developers. So I think I'm in the right audience here. So before we get into details, I'll talk a little bit about myself, get an idea about you guys, and then we can get more into exactly what GraphQL is and what the story is. So my name is Kito. I am the principal consultant at Vertua, where we do training, consulting, mentoring, web development, backend Java, front-end development, etc. And we've been doing that for a long time, almost 20 years. I'm a Java champion. I've been in the Java community process when that was a really big thing for enterprise Java. I have not really been too involved with the more core JCP processes, but I've been involved with like CDI and JSF and portlets. I'm a member of the Jakarta EE Guardian Leadership Council, and basically the Jakarta EE Guardians are just a grassroots group of people who are pushing to ensure that Jakarta EE continues to flourish under the Eclipse Foundation. So I'm just involved in that area. I'm a Google developer expert in web technologies. I'm also the co-host of the Stacked podcast. So if you like podcasts, I encourage you to check it out at stackedpodcast.com. And it is essentially, it comes out every month or two. We have guests on. We focus on enterprise Java, just front-end development, enterprise development in general. And we actually recently had Matt Rabel on. So if you want to hear him talk about all about his history and Okta and stuff like that, you should check it out. So if you like podcasts, I encourage you to add that to your podcatcher. I also speak at lots of conferences as well. So that's my story. I do want to get a handle on the audience. So I am going to ask that if you basically just give me in the chat a few words about whether you've worked with GraphQL or not, and what you're hoping to learn in the next hour or so. If we can throw that in the chat, that would be great. So if anyone's out there. So I was told there's a bit of a delay, so it might take a minute to show up. Okay. So one person worked with it with React and Elixir. That's cool. So another person is interested in consuming GraphQL APIs with minimal fuss in Java. Okay. Haven't used it, but interested. Have worked with GraphQL, but not that much. Started looking at it a little bit with 2.7.0. Okay, cool. All right, so we've got some people with experience and some people just looking to learn more. So that sounds great. Okay, so what is GraphQL? It is a different way to do client-server communication, essentially. So over the years, we've had a few different ways, right? Back in the day, we had, sort of protocol-specific or app-specific client-server apps where you just talk to the database, right? You'd have an ODBC driver on your Windows machine, and that would talk to a database. Then we decided to have a 3-tiered architectures where we had some code in between the client and the database. Different we've had different RPC mechanisms along the way, right? And whether it was back in the day with Corba, and then RMI in Java, and then of course all of the SOAP standards, etc. And REST, of course, reigns supreme. But GraphQL is another way to do essentially the same sort of thing. It's another way for your client code to talk to your server code. It is it's mostly about data, which again is, of course, what you're sending back and forth anyways. So this is a very simple example. On the left is a query, and on the right is the result. So on the left, you'd say, hey, I want all the heroes, and I only want the name property. I don't want any of that other stuff, just the name property. Give me the name property of all the heroes. And on the right, that is the result. So it's basically saying, hey, here's the data, here's the one hero, and here's that one property you cared about. And if there were multiple heroes, you would see several different names as well. So that's a very, very simple example. The key thing here, though, is there's not really, all the REST semantics don't actually exist here. So that's a key difference. It was created by Facebook in 2012 and open sourced in 2015. And here's what I'll say about Facebook. I'm not a huge fan of the company, but they put out some cool technology and they've open sourced it. So I think there's some great stuff out there, and GraphQL is a good example. And the reason they built it was they were trying to solve the problem of how can they efficiently transfer graphs of data back and forth to the client. And it does let you do that. So that's a basic core principle. And that efficiency aspect is something that we'll be talking about along the way. So the GraphQL Foundation started in 2017, and it's got lots of different companies in it. GraphQL is also used by lots of different companies as well. Let me see if I can shrink this down a bit. There we go. So you can see Starbucks in here, Lyft, Twitter, Intuit, GitHub, many other companies as well. So this is a little bit older, so there's probably others that I've left out here. Another one is Netflix. So, all right. So why would you want to use it? That's cool. There's another way to do the same thing we've been doing forever, which often happens in software development, right? What's the point? So here are some of the benefits. First, you basically get a single consolidated dynamic endpoint. So as opposed to having to manage lots of different endpoints and lots of different APIs and having a whole bunch of different, whoops, sorry about that, my bad. Wrong button there. This is, just pretend you'll see this soon. Here we go. There we go. So instead of having, several different APIs or several different endpoints that you have to write independently, there's basically just one endpoint called GraphQL, and that basically exposes your API. So it's a little bit easier to manage in that way. And it also has subscriptions. So subscriptions are the ability to say, give me some data whenever it changes, and then push it to me instead of letting me pull for it. And that's a really, really powerful feature. And to me, this is one of the most compelling features to use it for. And one of the ones which doesn't get quite as much press, but it's a really nice feature. Another thing is it has a defined data format. So when you write a REST API, you can send whatever data you want back and forth. You can make up a schema. You can get really involved and create open API schemas, etc. Or you can just send back JSON and leave the client to figure out what it is. But with GraphQL, you kind of have to define the data format. You can't. There's no like. You really have to. So there's actually a schema that has to be defined, and there are different ways to do it, and they are typed. So GraphQL has its own type system, and that is another one of the key benefits is having all that built in out of the box. So another key benefit, and this is where the performance comes in, is the client decides what data it wants, and the server decides where to get it. So often when you write REST endpoints, you find yourself sort of bending over backward to create different APIs or different endpoints for different use cases. And then also for, let's say the client has a new requirement, you then have to go and add, take in a new parameter and update a query and all that kind of stuff, which is not necessarily a bad thing, but there can be a decent amount of overhead involved in tailoring the API to match what the client really wants. So with GraphQL, you get away, that stuff doesn't go away completely, but you do make things a little bit easier because at the very least, for any given query, you can specify what data you want to get back. And that's a big deal. So you can say, I want the person object, but I only want the name, or I only want the ID, etc. And that translates into real performance savings because you don't have to send bytes that aren't necessary. So that's a nice thing. The other thing is that since you have a defined schema that defines your API, where you get it from is up to you. And this is generally true in any endpoint, but GraphQL is well suited for it because you can basically define schema and then have a resolver, which is what you call it in GraphQL terminology, or different resolvers grab the data from different locations. So you can have one that talks to database, one that talks to another service, one that talks to some other data source. And that's why we say it's well suited for BFFs, which are backends for front ends. So it's well suited for situations where you have a set of services already or a set of data sources, and you really just want to provide an easy to use API to your clients. So it's really well suited for that. And of course, it does try to address some of the drawbacks of REST. So, with REST, usually the endpoint decides what data is returned, or you end up adding a whole bunch of parameters to decide which data is returned. Sometimes data can be split among several different calls, and there's no specific data format. That really depends on the service, and that's up to the developers involved. The other thing is that there's no push standard. So if you wanted to push data back to the client, you have to roll it yourself. REST doesn't really have anything for you in that area. So let's start with a quick demo, sort of to get your feet wet. Just like any other, set of APIs that you need to work with, you need a tool to use to test it with. So of course you could use curl, but I'm too lazy to use curl, so I look for UI tools. The first choice might be Postman, right? But Postman, last I checked, had really bad GraphQL support. It's really limited. It may have changed in the last few months, but I've been using this tool called Altair GraphQL Client. Another popular tool is GraphQL, which is a React app that's easy to embed in your application. Tools like Altair are better suited, I think, if you're trying to hit endpoints that aren't, that you don't have total control over. So think of, Altair and other tools like it as light versions of Postman, but the same idea. You can have collections of requests, you can make requests from them, etc. So I'm going to start with a very simple example here, okay? And you notice it's already complaining about something. All right. Okay. So
can you bump your fonts a bit, Kito? It's a little hard to read there.
Yeah. Thank you. There we go. Big font here. Okay. Is that better? Is that good, Matt?
Yep. I mean, we'll always take it bigger, right? I'm getting old, so.
I know exactly what you mean. All right, we'll try this. Whew. All right. Okay, so on the left is the actual query itself. Okay, and let's just clear this so we can look at this. Okay, so we're saying we're basically creating a query. This is the name of the query. We can call it whatever we want, but we're calling it issues. And this is the actual query itself. Okay, so we're saying give me repositories, and I'm passing in some parameters into the query. So I want repositories by Kito99, which is my GitHub handle, name GitHub repo list, which is the name of the repo. And I want back the ID, the name, the number of issues, the total number of issues, the stargazer count, the primary language. And I only want the name from the primary language. So you see this is GitHub. So I can basically send this request and I get unexpected end of document error, which is a new error, which I shouldn't be getting. All right, so this has not happened before. Problem is, okay. So I've got data back now. And you'll see I've got the initial element or the initial property being data, and that's going to have the actual response. And you see I get the repository back, I get the ID, name, issues, total count, stargazer count, et cetera, et cetera. So I've got all that stuff coming back. And you notice those are exactly the fields I asked for. I basically only get the data back that I want. This is somewhat, it's typed in the sense that there is a schema, right? So I can't request things that don't exist, right? So if I do this, I get an error message back telling me undefined field, total name, total count, etc. Okay, and this is not coming from anyone's code. So even though I obviously I don't work for GitHub, I can't tell you what they've written. I know that the GraphQL engine itself does this work. So the GraphQL engine knows what the defined contract is, and it does this sort of it parses the request before it even gets to your code. So you get that sort of stuff for free. All right, so that's a very, very basic query. And
I have a question for you from Jimmy here. Are there any
Jimmy?
plugins for popular relational databases like SQL Server or Oracle where you can just, make it into a GraphQL server?
Yes. I don't know exactly particular ones for, I can't say, well, there's a great SQL Server one, but there are products that are essentially service products, so they do that kind of work. So we'll talk a little bit more about that as we get forward, but yes, that is totally possible. And what that does allow you to do is, avoid writing code when you're just basically pushing out data from a data source or a couple different data sources or even many different data sources. So the answer is yes. Okay, so let's take a look at the network traffic here. So I'm going to send my request again. Okay, and if you're wondering what's actually happening under the hood, this should give you an idea. So the endpoint, the URL, is just GraphQL. So this is the URL for the entire GitHub GraphQL API. And the requests are push requests. And the payload is this. So the operation name, which is the name of my query, and then the actual query, okay? And there's variables, which I'll talk about in a minute, okay? So that's what was sent, and the response is just, as you would expect, ordinary JSON. So it's pretty straightforward. It's basically just push requests from a HTTP perspective. Okay, so that's a very simple query. Let's take a look at some other queries as well. Altair will complain about some things. Okay. All right, so let's go back up here. make sure we've got our, hold on a second, let me go to basic queries. Make sure this is actually loaded. Okay, here we go. All right. So we've got this initial one again, okay? But you notice we've got things are a little bit different here. So we are looking for the prime faceless repository. And you notice for some of these properties, we can actually provide additional parameters. So we're saying we want issues, but we want to filter by open issues, and we want only the first 50, okay? And then we can also get like the edges here. So these is basically gives you the ability to sort of look at it from a graph perspective. So we want all the edges and node and title. So basically to see what they're related to. Okay, so see we've got the repository back, we've got the issues, and each issue has a node, and the node gives the title. So basically this gives us different names for different nodes, essentially, for issues, so different issues. And you don't have to always use this way of accessing things, but it gives you a little bit more flexibility. All right, so that's that one. We can also get in all of the repos back. So we're doing a search query, okay? We're looking for all the GraphQL Java repos. We only want the first 30. And you'll see we've got this interesting thing here. So this is what's called a fragment. Actually, this isn't technically a fragment, but basically what this is saying, fragments you'll see look similar to this. What this is saying is basically, okay, I want a node, but if it's a repository, because a node can be different types because there's polymorphism involved. So I want these properties. And basically this is saying only give me nodes of type repository. Okay, we also could be looking at other types as well and return properties for those. So I will do this.
I got a related question from Matt Henry here.
Mm-hmm.
He's wondering if you can add inputs or filters for nested objects.
Yes, you can. It's not something you get for free, but you can certainly do that. And a lot of it has to do with how you do your schema. So you see in this example, this is basically sort of that. But a better example of that is this. So you're basically saying, okay, for each repository, I want all the issues, but I want to filter those issues. So it's basically allowing you for a particular property to use what are called input parameters to decide what records to return. Okay. All right, so so this will only work for repository objects. If I were to take this out, right? Let's say I take out that, and then I'll take out this. So I get an error, and sessions can't be made directly on unions. Okay. So it's basically saying since this node can be different types, you need to specify the actual types that you're working with for it to work. So that's an example there. And this one, we're basically doing the same thing, but we're getting issues back. Okay, so that would look pretty similar to the other queries we've seen. So this gives you an example of some more things you can do with GraphQL. Another thing I want to show you are, let's do variables, okay. Okay, so this looks similar to the other ones, right? But we have this little $ query thing, okay? So this is a variable that we can pass into our query, and this variable is here, okay? So this basically lets you parameterize things. So you might have this query on whatever client is making the GraphQL request and then just pass in this as parameters that let you essentially, change that value dynamically. So if I do this here, okay, I'm basically getting all of the repositories that match this query value circuit breaker, Okay. And you see there's a lot here. Spring Cloud Circuit Breaker. Surprise, surprise. And if we look at the network request for this, you can see that the variables are filled in here now. So now we actually are sending something inside of the variables here. So the query is not going to have that variable filled in, but you can just pass in whatever parameters dynamically, or when you make the query. So it's another thing you can do. You can parameterize your queries. What you can also do are use fragments, which is what I alluded to before. So here, this is basically the example I showed you before, where you're saying, okay, for this particular type, let me grab these properties. But you could also throw that into a fragment as well. And then if you do that, you can basically just include the fragment. Whoops. You can include the fragment there. So fragments just allow you to include arbitrary pieces of GraphQL queries that you can then include in your queries. So it's another way to reuse things. So that's another key feature.
All right, I got another question for you.
Yep.
I didn't quite understand it, but hopefully you will. Is it true to say that GraphQL needs another method to send a GraphQL query from clients to servers and to send a GraphQL response from servers to clients? For example, REST.
Not exactly. It's true to say that GraphQL does not specify the transport mechanism. So GraphQL doesn't care. Honey Badger don't care. But 99% of the time, it just goes over standard HTTP, not really REST per se. So REST has, understands verbs and like post, get, etc. But they all have semantic meaning. For GraphQL, that doesn't really matter. I mean, you really just usually, you don't have to, but you usually just do a normal HTTP post request. Now, it is possible to do normal GraphQL requests over other transports. You can even do them over WebSocket if you wanted. But usually it's post. But it is true that the specification does not make that, that's not like a part of the specification. So hopefully that answers your question. Okay, so we got that part. And another thing I wanted to show are directives. So you can see how you might want to, do some funky things inside your query, like only show the language if it's a certain language, or skip part of the query based on some condition. These are called directives. So they're kind of like special features that you can put inside of your queries. Right now, there's only two. There's include and skip, and they're both conditional, just based on if some condition. And this condition here is a variable that's being passed in, which would seem logical to do for this. Now, the thing is, directives are an extension point. So any particular GraphQL implementation can add its own verbs or its own directives that do whatever it needs. So whenever you start using some specialized GraphQL server or service, it may have its own directives. And also, if you are writing your own GraphQL endpoint, you can usually, depending on what libraries you're using, you can usually define your own directives as well. So it just allows you to extend the language. So it's a pretty cool feature. All right, so everything we've talked about so far has been all about reading data, right? But you can also update data as well. And when you update data with GraphQL, it's called a mutation. And mutations look pretty much the same as what we've seen so far. So I'll move this out. So instead of query, you say mutation, and then you basically use the actual mutation name, which is sort of like a method call, but not technically. And then you specify input parameters. And then you also say what you want back after the mutation is complete. So here we're saying we want to create an issue for a particular repo. And then after we've created it, we want to get the issue back in some properties. So you can do this, and we get that we've created an issue by me with the title demo and the body demo. And I believe, oh, I don't have it here. Yeah, so if I had the actual repo up, I would show you where it was created. But this is actually created on a real, public GitHub repo. So that's an example of a mutation. So they're pretty straightforward. All right, so that's sort of the quick overview of sort of the basic syntax and the basic way that GraphQL works. What I've left out is a very important piece of it, which is, what about the schema, right? So you can see how you can create a query, you can get data back, but I also said there's a type system and schema, and that's the other part that's missing here. So it turns out you can actually grab the whole schema for GitHub, and that's what we have here. So the schema for GitHub is really big. You'll notice it is quite a few lines. So if you go all the way to the end here, you'll see it's 40,000 lines. So it's a pretty big schema. Now, most organizations will not have a schema this large, but this is what it looks like. And you see all already at the top, there are some directives that are here, and these are specific to GitHub or whatever engine they're using. I've not seen them before. But where I want to start is with the query. So if I do query, this is essentially the entry point to all of this API from a read-only standpoint. Mutation is a different entry point. So you can put comments in here. So this is a comment that describes what this is. So the query root of GitHub's GraphQL interfaces. And then inside of here, we have all of the different queries that you can perform against GitHub. Okay, and we can look at. Hold on a second. Okay. We can look at a few different things here. First, if we pick, let's see, issue. Okay, so this is an issue type here, and actually this is not the one I wanted. Okay, and we'll go down here, and I think the top level that we were looking at was repository, right? So if we looked at a repository, we can get the name and the owner, right? And it returns a repository. And you notice that there are primitives, so this is a string, okay? And this is basically saying whether or not it's required. And of course it is required. And then here is the repository, okay? And you notice a few things here. The repository implements interfaces, node, package owner, or basically types, essentially. So it is all of these things, okay? And then of course it has its own properties. And these are what the front end is going to be requesting, right? So code of conduct, etc. And for any one of these, you can define additional parameters that are required. So this is what we've seen. And you notice some of these are optional and some are not, okay? So inside of here, you see some other primitives, datetime, int. Datetime is not actually a primitive. This is a custom type. Date is sort of not part of GraphQL. But int is, boolean is, etc. If we go down here, we'll find the issues. There we go. There's issue. So this is what we were looking at before. And an issue is all of these things as well. And so you can basically create a really rich schema. And you notice each one of these assignable, they only have a couple of properties, assignees, etc. And you see they've really gotten very rich types here. And URI is defined as a scalar type, which is supported. Okay. There are also enums. So here's the repository permission enum that looks pretty much like you would expect. Admin, read, triage, etc., etc. So this is basically what a schema looks like. And there's a few different ways to generate it. But other than providing that essential contract between the client and the server, there's also some other nice benefits it provides, which is essentially the same benefits you get with Swagger. Although I think it's a little bit richer. So if I go back to my queries here, okay, let's say I go back to simple query. All right, so one of the things I didn't show is that you can get a little bit more information. So I didn't click on this here, but there are docs, right? And maybe the docs. Okay, so we can see query.
I have a question for you while that's loading.
Mm-hmm.
This is from Mike. Are there any recommended GraphQL implementations? He's been building AWS Amplify applications where the API is GraphQL, and that's implemented by AWS AppSync.
Yeah, I think it really depends. I've been looking at Amplify recently just to see what it's like. Because for me, it's fairly new. So most of my work has been looking more at, like, you know, if I'm writing code, what code do I need to write to expose GraphQL? So like what I'll be demoing today is just MicroProfile GraphQL with the microservice on Quarkus. But Spring actually just released their GraphQL project 1.0 recently. There's also other ones which I'll go over, and there's also a whole bunch of stuff on Node, of course. So it kind of depends on what you want. Like, you know, Amplify is great if you've got a whole bunch of stuff in Amazon and you don't want to write code for it, and you want to let Amazon sort of federate, or not federate, but combine with lots of data sources and just write a few lambdas if you have to. And there's some other options along those realms, those areas as well that we can talk about, but it really depends on what you want to do. So hopefully that helps. So just really quickly, all of this information here is coming directly from the schema. So basically the schema lets you have really cool docs, right? Just the same way you would in Swagger. And of course, if you have a good client, or a good tool, you can, you know, iterate through all the docs and get a lot of information. All of that metadata is also useful for this, for code completion. So I can basically just pick the properties that I want and then add them here. So all this comes from the schema. And this is something that, you know, I don't get when I'm using Postman, is actual code completion for the queries I'm creating. So I like this feature a lot. That's why it can know, like if I do this, it knows that's an invalid property to use as well. Same thing goes for, you know, these attributes as well. So I know I can do file renames, and that's true. And, you know, then I can start on the query, and I'll get some data back. So that's another sort of main benefit you get by having that schema. So there's some other things about schemas which are cool too. So we talked about it being a type-safe contract. The client can only request data defined in schema. You can't request anything else. And another different thing is that versioning is handled through deprecation, and this is a good thing and a bad thing. So usually with REST, you version your API, right? So you have V1, it lives for a while, and then you have V2, et cetera, et cetera. With GraphQL, you can just deprecate stuff. There's a deprecation annotation you can provide, which, you know, is easier to manage. It means, and it gets rid of having big versions, but it also means you have to really think about it along the way and make sure that your clients upgrade so you can get rid of deprecated things, as opposed to just deprecating them and letting them live forever. So you know, if you were saying I'm creating version 2 of the API, it's a little bit easier, I think, for people to understand than that I need to change these 3 parts of my queries because they've been deprecated. So I think it's pros and cons. I think it's easier in the beginning to do the deprecation. Yeah, the demo. I want to point out a couple things about design approaches for GraphQL for schemas, and there's two main ways to design things. There is schema first and code first. So schema first basically says, I'm going to hang out with all the stakeholders, the backend developers, front-end developers, or maybe other backend developers, whoever's consuming the APIs and whoever is creating it, and define the schema. I like this approach. I've used it before. What it does is it forces you to think about what it is with the people that are involved. And the other thing that allows you to do is to have the consumer of the API actually write their code before it's done, which is kind of cool. So because you have the schema, they can just write their code against the schema. And they can even generate resolvers that create fake data, which is what we did. So you do all that kind of stuff. And then when the code for actually implementing the schema is done, or as it becomes done, you can swap out the mocks or whatever with the real thing. So that's kind of a nice thing. But it requires more upfront work, right? And code first, which is the alternate approach, means you just write your code and then it generates the schema dynamically for you. And that obviously is going to be a little bit faster up front. But I think what it does is basically say that whoever is building that code it has more control, right? Because they're the one building out the schema. They're, writing essentially an object model or some sort of model which whatever library they're using is going to be translating into GraphQL. So it just depends on sort of what you want. But of course, you need to make the decision up front because clearly it would be a difficult thing to change later on. So something to keep in mind.
We got a question here from Mike again. Is there no versioning with GraphQL, meaning only deprecation? How REST APIs might have a V1, V2 kind of thing.
Yep, there is only deprecation. There's no versioning. So I'm sure if you really wanted to, you could emulate that, but there's certainly nothing built in for it, and it's not really expected. It's expected that you will only use deprecation. So that's the deal there. Okay, so that's schemas. I want to talk a little bit about subscriptions. And as I said before, they let you push data from the server to the client. It's also transport independent. So GraphQL in general doesn't care what the transport mechanism is. But like with normal queries, there is a default, and the default implementation is WebSocket. I've also seen some server-side events, but that didn't really seem to work out when I was looking into it, but that was a while ago. But also I've seen like MMQT, is it MQT? It's the IoT protocol for messaging. So like it doesn't really matter what it is. So there's lots of choices if you're willing to find, if you really have a specific use case where WebSocket is not going to work, chances are you can find something else, which is pretty cool. So let's take a look at how that works. Okay, so I have with me, I have a little demo app running that has a very simple subscription. So here I have my sample app, and I'm going to show you the JavaScript code. Okay, so I'm going to click on this button here, connect, and you see I have this 1, 2, etc. Okay, and what's happening is I have make this bigger for Matt's eyes there. I have, that's actually too big. Okay, so I've got a GraphQL, I have a WebSocket open here. And we notice the initial query is say, hey, give me a subscription, random person, ID names, operation name, etc. Okay, so this is basically just it's a very simple query. It's doing a subscription to something called random person. And then each time the server is sending back a new random person, I get a new frame in my WebSocket, which is currently open. Okay, and you can see it's updating here. I'm now up to 29. Okay, so the JavaScript code for this is really straightforward. This is actually a web component. It's not a React app or anything like that. It's very straightforward. But when you click on the button, it basically is going to open this WebSocket here. Send the request, and then it's basically just pushing on each message it gets back from the WebSocket. It's just pushing data back into the view. So it's pretty straightforward here. Now, so this isn't using any special GraphQL API or anything. You certainly can. There's nothing to keep you from doing that. But this is just showing that it's really a straight up WebSocket request. There's nothing special going on here. So, so that's an example of the joys of subscriptions. Okay. So any questions about subscriptions before I move on? Okay. All right. So let's talk about a couple more things. So implementations, this is where sort of the meat is. So there are a lot of client-side implementations, as you can imagine, because, you know, obviously you want your client code to be able to consume GraphQL. So basically any language you have interested in has support, whether it's JavaScript, of course, which is where you'll find most of it. But basically any other language you can think of has an implementation for GraphQL. So what you'll find though on the JavaScript side, that Apollo GraphQL is the most popular one, but there are other ones as well. So basically, you know, depending on the language you want, you just take a look at the possibilities there are, and there's a lot out there. I'll talk about Java specifically, but for the front end, you know, it's pretty much Apollo GraphQL or some other one. And of course, if you're using a language other than JavaScript, it depends on the languages that the options in the ecosystem. Okay, I did want to do a special shout out for Apollo Elements though. So if anyone who follows me knows that I'm really into web components when it comes to front end development. I'm not particularly into a lot of frameworks, although I work on a daily basis with React or Angular or whatever. But one framework I thought, not framework, but one library which I thought was useful was Apollo Elements. And Apollo Elements is basically a set of web components that wrap the Apollo GraphQL library. So it allows you to declaratively make queries using GraphQL. And since they're web components is a standard for building components inside of web browsers. So it works with any framework these days. So you can use it with vanilla HTML, lit, which is a way to write web components, fast, etc. All these are web component libraries, but also you can use it with Angular, Preact, React, Svet, which I can never pronounce, or Vue, etc. So you can use it with any of these. So this is, to me, is a great way to use Apollo and use GraphQL, because it's easy to just get your feet wet and get playing with it. So I wanted to give a shout out to that. Okay, so now the Java side of things. So on the server side, of course, you don't have to use Java. There's lots of Node options, and there's also an Apollo server-side option for Node. But I will talk about Java, because this is a Java users group. So so GraphQL Java Tools is one that's out there. And one thing I did want to point out, I'm just going to jump over here. So GraphQL Java Tools gives you a way to do schema first development in Java. So that way, if you have a schema, you can use GraphQL Java Tools to do it. And what you'll find, though, is that if you type in, like, you know, Java GraphQL, right, you'll find is this, GraphQL Java, okay? And it says the Java implementation of GraphQL. And that is pretty definitive, because almost anything you find will be built on top of this. There's a couple exceptions. GraphQL Java tools builds on top of it. Spring builds on top of it. My MicroProfile builds on top of it. So it's sort of a low-level API. So if you're looking to really use GraphQL in a production app, this is probably not where you want to start. You probably want to start with whatever works for what microservices framework you're using or whatever. But if you want to really understand in detail how GraphQL works in Java, then you can take a look at this. And the tutorial is pretty good. So GraphQL Java tools, which I've used before, makes it really easy to do schema first stuff on top of the GraphQL Java API. There's also this domain graph service, and this is actually from Netflix. So they have their own tool, which is pretty powerful, and it's specifically for Spring Boot. And you can use Java or Kotlin. So I can't say I have any experience with this, but it looks very well. It's well maintained, full featured, and it of course is from the folks at Netflix. So it's pretty robust. So that's an option. I think they just released that last year. One that I've been looking at is MicroProfile GraphQL. So MicroProfile is microservices, a set of microservices APIs that you'll find in servers like Quarkus or Web3 Liberty, or Open Liberty, I should say, or Pyara, etc. This has support for basic GraphQL queries and mutations, and using the whole MicroProfile, or using the whole MicroProfile / Jakarta EE APIs. So it's really nice in that way. Spring GraphQL is new, I mentioned. It has basically the same sort of things, full support for GraphQL queries, mutations. It also has really good support for subscriptions as well, which MicroProfile GraphQL does not. So and they just released 1.0, so I definitely think it's worth looking at. And as I mentioned, on the server side, for Node, Apollo Server is probably the most popular one. They also have this new product called Apollo Federation, which makes it easy to combine several different graphs from different sources. So that's a good idea if you're a large organization and you have lots of different GraphQL APIs. The Federation features let you combine them all into a single view of one big API. So those are the server choices. I'm going to do a quick demo here. And Matt, how much more time do I have? Because I neglected to review the exact limit of the time.
I think we should probably wrap it up before midnight.
I think I can handle that, indeed. Okay. All right, so here's the demo. Let me find it over here.
We do have a question while you're getting that going.
Sure.
Do you know if AWS AppSync is built on top of GraphQL Java?
I do not know. I never know what they build stuff on top of, to be honest. I worked with one person who worked for AWS, and he basically said it's like all held together with glue and duct tape. But that was just one person's perspective. But I've worked with AWS a lot, but I've not worked with Amplify, so I don't really know much about it in the way I'm looking at it now. And they use a lot of Java, so I wouldn't be surprised either way, to be honest. So
okay, so if anyone knows, throw it in the chat and
yes, please
answer Ava's question. That'd be great.
I'd love to know. Okay, so I'm going to show. That's lovely, isn't it? I'm going to show MicroProfile, and I think the Spring Boot experience would be similar. So I'm going to run my Quarkus dev server. Okay. All right, and I think there's some. If I press that, there we go. Okay, so now I have my lovely little example. Kudos to Philip Kruger, who's the lead developer for the GraphQL MicroProfile GraphQL stuff. So this is his demo. I will not take credit for it. And in the demo, they have both a REST and GraphQL versions of the same API. So In my Altair example, I have some for my MicroProfile as well. Okay, so I can do a query for people, and I can get the properties back. So I'll try that first. All right, and lo and behold, I get some people back. And each one, they have the names, surname, etc., birth date. And they also have scores too. Okay. So keeping track of their scores. So it's a very simple query, right? And the way this is implemented, no, it's hard to see here, but I will go here. Does that actually zoom in, Matt, if I do that?
Yep, it does.
Cool. Okay. All right. So this is the demo, and it's, I'm sorry, not that one. This is the demo. There we go. And I'm looking at this example here. And all of these different APIs I provide, a lot of them will have client and server APIs. So MicroProfile has ways that you as a Java server, Java service, excuse me, can query a MicroProfile, a GraphQL service as well. So you can either, you can consume GraphQL and you can also expose GraphQL. But we'll be looking at exposing it right now. So it's a normal Java app. There's nothing really special here. It has a normal POM. And we have a person GraphQL API. Okay, so which I need to actually open first. Okay, so this is a very simple POJO. I guess we still use that term. And we're using MicroProfile uses CDI, but it's the same idea with Spring and dependency injection. So we're injecting whatever services we want. And then we, of course, have this GraphQL API annotation up here. And then for any methods we want to expose, we can just use this query annotation. And then, of course, we can use normal metrics. And this is one of the nice things about this, because the work I did before with the GraphQL tools, GraphQL Java tools, you had to basically figure out how to integrate metrics yourself. So it's nice to have this done automatically for you. And basically, we just do a normal method call, or basically, return an object, return whatever we need. So this is that get people query, okay? We basically return all of the people, okay? So what's interesting here is this is the query, right? It returns a list of people, okay? If I go back to the browser, this is the query. It returns all the people, right? But you'll notice that in the Java version, I'm just returning the whole object, right? Whereas here, I don't need to request the whole object. So I could ask for just the name if I wanted. So even though all the data is being returned, the GraphQL layer is basically saying, okay, I'm only going to send back this data. So it makes it a little bit easier on the developer because they don't have to worry about it. And that way, the client can just specify what they want without the developer having to parameterize the query. So that's one. Another query is scores. So let's just add that one. Okay, I'm sorry, that's not a query. It looks like a query, but it's not. Okay, so this is actually a good thing to point out here. Okay, so you see this down here. So we've got this people, right? We have ID, name, surname, whatever. We also have scores. So this is an example of data that's coming from a different location. Okay, so the scores here are coming from this method here. And you notice that we've got a kind of a special case where it's only allowed for admins. And the deal is, because of this source annotation, this is basically saying that there's going to be a property on each person called scores, which this method is responsible for resolving. And again, the term for retrieving data is usually called a resolver. So that's how scores work. Basically, scores are going to call this particular method off of people. Okay. So for example, if I did this, if I did let's say I did that. Okay, let's make sure I'm actually reloading properly. Okay. So if I do this, I run my query, I should see that output, right? Because the scores got called. And let's see if what we're seeing here. Okay, I did not see that output. All right. I love it when you try to freestyle during a demo. It never seems to work. Let's try this one more time. Okay, now I'm not seeing my output. Okay, but that's what should happen. All right, so but that is basically the way this particular API works, is that the scores method is called. Actually, I think I know. Now I see why. And this one instead. There we go. Okay, I'm not crazy. All right, so there were actually two get scores methods here. One gets it for an individual, and one gets it for a whole batch. This is actually more efficient, right? So this was the one being called, which is why I wasn't seeing the results. So obviously, if I take scores out of the query, I'm not going to see that in there. So if I get rid of this, and run the query, I'm not going to see that output. So that's how the nested queries work, basically by allowing you to use the source annotation. Now we've also got mutations. So I can create a new person with a wonderful name here. So I'll create a new Kito. So then it gives me the data back, right? And I requested this data back. Now, let's say I can create another one. So now I've got two Kitos. And then I can also get that data back, right? So I can query only a specific person, and then I can get Kito Mann back, okay? So the way the mutation works is pretty much the same idea. You just create a method, give it the mutation annotation, and then do your work, and of course return the object that needs to be returned as well. So that's pretty straightforward. So that's the way that works, and then there's some queries in here, etc. And this GraphQL schema builder, this name is really, really well deserved, because this is part of the GraphQL Java API. So this is basically leaking out the details of the implementation, which some cases are useful because the builder gives you more control over how the query is created. So that's a very quick example of what a GraphQL endpoint might look like. And you see it really just depends largely on the APIs you're using. So if you're using something like Spring Boot or MicroProfile, you're going to get a really nice, easy to use way to implement it. If you're using something else, it may be a little bit more work, but at this point, if you look at the Java choices, they're pretty powerful. I think when I did it, I was working with something called Drop Wizard, so it wasn't quite as straightforward as this. But these, if you're using something more modern, you'll find some great choices out there.
All right, we got another question. If we want to secure a field that isn't a nested object, do we have to use a custom data fetcher?
That's a good question. If you want to secure, can you repeat the question again?
You want to secure a field that isn't a nested object, right? So I assume that's, top level field.
Yep.
Do we have to use a custom data fetcher?
No, I mean, not in this scenario. But usually you might have to write your own data fetcher anyways, if depending on what data source you're talking to. But in this scenario, you don't, because this is all going to be, you can either be using the built-in security stuff that MicroProfile and Jakarta EE provide, or you can roll your own. But basically what's going to happen is, there's an interceptor that's going to be hit before this call. And this is all CDI. So you could do it at the top level here without any problem. You don't have to worry about the GraphQL API for that part. Hopefully that answers your question.
We got another one here.
Mm-hmm.
Do you use JPA to get people? If yes, is there any lazy fetch property in the person class? If yes, do you have to copy person to a regular POJO?
Oh, that's a good question. Let's see. This is a sample app, so I'm guessing it's not that sophisticated, but let's see how it's implemented. Yeah, so there's no laziness here. This is all just select everything. I would suspect, I do not really answer that question. I don't see why it would care whether it was, as long as whatever properties were called were handled by the collection to load more records. I would think it would be okay. But I don't know specifically. I have not tried that specifically, so I do not know. But you can certainly use JPA. And I think it should certainly be possible to do it with lazy loading. Any other questions on the Java side?
We just had a follow-up from Matt who said about securing, the custom data fetcher stuff. He wanted to secure a subset of top-level fields, right? Not just single one.
Subset of the individual fields. I see. That's an interesting question. I think using with MicroProfile, you probably could do a lot of that with this source annotation. But yeah, I see what he's saying. Like the data fetcher itself, you may need to have it say, okay, you're Joe Schmo, you're an admin, I'm allowing you to get to these fields. So that I think that might be a good case for one. Although if it were for simpler cases, you could just use this source annotation or the equivalent in whatever framework you're using. Because I could easily say, you see here, this is already saying roles allowed for scores. So this is saying only an admin can access the scores. So there was one more thing I did want to show. If I go over here and I pick ID 0 to generate that exception. Okay. So so what's happening is I put ID 0, which is going to throw this scores not available exception. Okay. And hopefully I can actually spell. Available. There we go. Okay, so that throw an exception, and what we get back is this. Okay, so we get this errors, and you can send multiple errors back. Tells you where it is, line 39, which is right here. So where it is in your query, the path, person, the exception that occurred. And then you can also get data back. So this is an interesting thing. So even though you can have one or more errors coming back, you also can still return data. And this allows you in situations where you're grabbing data from multiple data sources, you can throw an exception for one, but still send partial results back, which is kind of nice. But what I wanted to underscore here is that you see the exception being thrown here is not very helpful. It's not actually what happened. It's sort of been obfuscated. So you may, depending on what API you're using, what GraphQL implementation, you may have to do some extra work if you want this to be more meaningful to the client. So I know I've had to do that in the past, and I think MicroProfile has some features to do it now. But in the past, I had to, kind of hook into what GraphQL Java was doing in order to give them better exceptions. So something to keep in mind. All right, so let me move on. So we talked about GraphQL implementing it, in a microservice essentially for Java, or a right-sized service, or some server-side Java application, or a Node application. But there are also lots of tools as well. These tools, of course, just make it easier to do things, right? So if you're using Angular, there's Apollo Angular on the client. There's actually an Apollo CLI, which I've not worked with because when I was doing stuff, it wasn't out yet. But presumably just makes it easier to do a lot of common GraphQL operations. There's lots of code generation tools. There's tools which will allow you to, say, given a schema, generate TypeScript code or Java code from it. Those are pretty handy. And as you can see, there's also Swift libraries for GraphQL, etc. So there's lots of stuff there. And a lot of these things you can find on the GraphQL website. So this is really just landscape.graphql.org. So if you go to graphql.org, you can find all this stuff. And for each one of these, it gives you some more details about it, the license, etc. So this is a pretty handy thing. Okay, so those are the tools. There's also databases. So someone asked earlier about whether you can use SQL Server or some of the database and have it turned into GraphQL, and the answer is yes. But there's also databases which have native support for GraphQL. And you'll find those in databases which are much more sort of object-oriented or document-oriented databases. So these are some that have native support for GraphQL right now. And the one I was looking at actually was Neo4j, which has some really cool stuff. But there's other ones out there as well, as you can see. So if you are using an object database or a graph database as it is, chances are they're going to be adding, or they have already added, GraphQL support. And then there's services. So services are generally going to be some cloud option. Okay, so you can see here AWS AppSync, which we talked about a couple times, and AppSync has the ability to basically build a GraphQL API from different data sources inside of the Amazon ecosystem. So you can create a GraphQL API from different microservices. You can create it from DynamoDB. I think you can do it from other databases in Amazon as well. And you can also write lambdas to generate parts of the GraphQL API and all that kind of stuff. So looks pretty cool. Azure API Management, I have not worked with. I don't know much about it, but I presume it's similar to AppSync. And the only other one of these I know about is StepZen. And StepZen, I think, is probably a good choice if you've got a whole bunch of different data sources and you just want to slap a GraphQL API in front of them, because that's basically what it does. And they have adapters for like every single database you can think of. And they make it very easy. They have a lot of special directives for pulling data from different data sources. And it's of course a cloud option. So you basically just pay a monthly fee and it integrates with whatever cloud providers you want. So that's another one to look at. And so there's other ones as well, and those are all on the GraphQL org site as well. Okay, so hopefully I've made a case for why you might want to use GraphQL. I can also tell you a little bit about why you might not want to use GraphQL, because there is no silver bullet, right? I did this presentation once, and someone said, "Isn't this what everybody's using now?" And I was like, "Not what I see. It really depends, I think it may be in certain circles that's what everyone uses, but as far as I see, plenty of people still use REST APIs. So some of the drawbacks, maybe you don't want typed schemas. Maybe it's like too much overhead for what you're trying to achieve, right? Maybe you don't want the client to know exactly what data it needs to get. You just want to say, okay, here's the data that we have. Do whatever you want with it. You don't want the client to really worry about gathering different fields, or maybe the client always needs all those fields. Then the ability to specify which fields you want isn't really a big deal, right? Then there is, there's additional overhead. I'm not going to say it's slow because I don't think it is. But I don't really see how having this whole layer that's parsing your queries and doing all this stuff before it hits your code is going to be faster than hitting your code directly. Whether that overhead is important or not, depends on your application. But since there is stuff going on before it hits your code, there's additional overhead involved in processing the request. Also, it's not Rest. Rest is really popular. Everybody understands it, who's written front end or back end code these days. So you don't have to retrain anyone. And if you're just doing something simple, it's really all you need, especially if you're doing mostly writes. GraphQL doesn't really give you that much. Also, there's more magic, and some people are anti-magic. And by that, what I mean is there's a lot of stuff going on that you don't see before it hits your code. And in some ways, that's great because you have less code to write and maintain. In some ways, that's bad because when something goes wrong, sometimes it's harder to figure out what's going on. So it depends on your magic threshold. And of course, there are benefits of Rest, right? It's really easy to get started with Rest. I would argue that it's probably easier than it is with GraphQL. And as I said before, it's better suited for read-only or low data APIs. And it's Rest. And you can do whatever you want. You can return different data formats. You can even return XML if you need to. You can return JSON. You can return whatever you want. There's no particular rule. So it gives you more flexibility. All right, so that's pretty much it. I have some resources. I'll make sure that the links for the slides and everything are given out. But there's some articles about, schema first versus code first approach. MicroProfile GraphQL stuff, some tutorials, things like that. So some good resources for you out there. And that's pretty much it. Any questions?
All right, we got one. I'll bring Chris back up here as well. From Mark, does the Java implementation handle N+1 queries?
Explain in a little more detail what you mean by that.
I'm not gonna because I don't mean anything, but hopefully Mark will get back here. And then we got a Spring Boot is magic statement. Not really a question.
It's true. It's true. They're all magic at this point. And this is why I worked in a team that uses Drop Wizard, because there's less magic. They're like
well, but when Drop Wizard started, it was also magic because we were like, "What? You put a web server in your app? Like,
yes.
What the hell?"
Yes, this is true.
And everyone does it, right? So they were a pioneer in that sense.
Yep.
What about you, Chris? You got any questions, or have you used GraphQL, or haven't touched it?
Yeah, I've had some exposure to it. It's very, very cool stuff. So, but not in a production setting.
Okay. Actually, I have a project I'm working on that one I told you about, Matt. I think I'm probably going to end up using it for that because there's a lot of interesting relationships, which I think will be good for traversing with it. But I think there are situations where if you're just doing a whole bunch of things which are not, there aren't a lot of queries involved, it's not really necessary.
Right, so we got the N+1 back from Mark here. If I get back a list of items, do we have to query for each one? Right, so you get back a list, and then you want like the heavy list.
Yeah. I think you'd have to decide if you wanted them all back initially. You'd have to ask for them up, during the initial query, which you could do. But yeah, you basically are going to have to say, okay, this is the data I want now. If you want other data after that request, you're going to have to request it independently.
Right. So rather than just getting the list, you might want to put the fields in there that you want for each entity as well.
Exactly.
Right?
Exactly. And that allows the backend to, if that can optimize things that way if it needs to.
Can you do some kind of operator like occurs in? this list of IDs?
You can, but that's going to be a schema thing. So the same way like the GitHub API has those, filters that you can apply.
Right.
That's because they decided to put that in schema and implemented it. So it's not built in automatically, but you can certainly design your schema that way.
This is a great.
I did put in a couple of minutes ago if anyone had any more questions. So the fact that they aren't really rolling in, I think, means we might be good to go. We do have a suggestion here from Anbu that Java data loader tries to solve the n+1 problem. So
Interesting.
that might be something to look at.
Java data loader.
I will say, I don't know if it's the topic or you, Kito. I like to think it's you, but this is probably the most interaction we've had, like, on a Denver Jug, like, virtual meetup.
Oh, really?
in like a year, yeah. I mean, there's just been tons of questions and stuff, so that's pretty cool.
That's good to know. It's so hard with the virtual ones because there was one I did recently where it was like I felt like I was like pulling for like, just some like, are you really there? Like, but yeah, right. This has been great. So thanks to everybody for having me. Appreciate it.
Yeah, thanks for coming. And since nothing else is really rolling in, I think we'll let everyone get on with their lives. And if you're in Colorado, it's still nice and sunny out, so maybe take a walk and enjoy it. And if you're elsewhere, enjoy the rest of your evening or the start of your day. And we'll see you next time.
All right. Thanks a lot. See you later.